Okay, going back to some linear algebra then, some simultaneous equations. We might have two sets of, or a set of two simultaneous equations in x and y, 2x plus 3y plus 2 equals 0, and 3x plus 4y plus 6 equals 0, and they are equations 1 and equation 2. Okay, we can find the solution to these equations. So we want to find the first value of x by eliminating y, for example. So we multiply this first equation, equation 1, by 4, and we multiply equation 2 by 3, and we get, so we're multiplying this one by 4, 2 4s are 8x, plus 12y plus 8 equals 0, and we can call that 1a if we like, and then multiplying this equation by 3 by this coefficient of y here, so we get 3 3s are 9 x plus 3 4s are 12y, and we see why we've done that now, because we've got the 12y's common. So 6 times 3 is 18 equals 0, 0 times 3 being 0, and we have a second equation which we could call 2a. Okay, and then by subtraction we could take one from the other, and we will take, let's take this one from this one. 9 minus 8 is x, plus 0, these cancel out, plus 18 minus 8 is 10 equals 0, therefore x equals minus 10. Okay, which is the solution, which we now plug back into one of the original equations, and then obtain, let's plug that x value into here. 2 10s are 20, plus 3y plus 2 equals 0, so y equals minus 20 minus 2, sorry, 3y equals that. So y is equal to minus 22 divided by 3. I've done something wrong there. This is actually, sorry, x is minus 10, so 2x is minus 20, so that 20 becomes a plus 20, plus 20 minus 2 is plus 18, 18 on 3 is 6, so that's better. Y equals 6, x equals minus 10. It's important to keep track of your negatives. So x is minus 10, so 2 lots of minus 10 are minus 20, not 20 as I originally put in there. So yeah, so y equals 6, x equals minus 10. Okay, so the key to that was then that if we say that that equation is of the form ax plus by plus c equals 0, and we've got two of those, so we say a1, b1 and c1, and then in this one a2x plus b2y plus c2 equals 0. So we've got these different coefficients. A1 is 2, b1 is 3, c1 is 2. Okay, if we then come down to this stage here, what we did was we multiplied this equation by this coefficient b2 here. Okay, so we ended up with an equation a1b2 x plus b1b2y plus c1 b2 is equal to 0. 0 times b2, if you like. And similarly, sorry, that's that equation here. And then this equation is we multiplied these coefficients by our b1, so we ended up with a2 b1 x plus b2 b1 y plus c2 b1 is equal to 0 times 0 times b1, if you like, or 0. So subtracting then one from the other, so if we take, we did it the other way around here because it was convenient to take the smaller numbers from the larger numbers, but it doesn't matter which way you do it. And indeed, we could call this 2 and this 1, therefore these would represent the opposite equations, simultaneous equations. So in the general case, then we can take this equation minus this equation, the key being that these are the same. So if we take this one from this one, these ones cancel out, so we are left with the general case equals a1 b2 x minus, and we'll take the x out as a common factor, a2 b1, so all these are multiplied by x, so this is this, take away this, and that or rather if we then we're left with plus this one, take away this one, c1 b2 minus c2 b1 is equal to 0. These ones, that subtracting that gives us 0. So we're left with this general equation here, and then we can rearrange that such that a1 b2 minus a2 b1 x is therefore equal to c2 b1 minus c1 b2. As we change the side, we change the sign for those. So therefore x, we can rearrange this. This equals, let me just swap those round. So c2 b1 is the same as b1 c2. So I'll call that B1 C2 minus, and again, B2 C1. Okay, and then that is divided by these coefficients, which are our A1 B2 minus A2 B1. Okay, that's equal to. So if we take our coefficients in this specific case, then these are the general case. But if we now apply that to the specific case, B1 is 2, C2 is 4, so that is 8 minus B2. Sorry, I've done that the wrong way around. 3 B1 is 3, C2 is 6. So 3 6s are 18. And then this one here, B2 and C1. B2 is 4, C1 is 2, 2 4s are 8. So we have 18 minus 8 on the top, which is equal to 10. A1 is 2, B2 is 4, 2 4s are 8. And then we are subtracting A2 is 3, B1 is 3, 3 3s are 9, subtracting 9, 8 minus 9 is minus 1, so we get our the same result. X equals to 10 over minus 1 is minus 10. So that's the same answer that we got here. Okay, as long as in this general case, as long as this denominator here is non-zero, doesn't equal 0, then we have a finite solution to these simultaneous equations. If these, interestingly, if these came to, if A1 minus A1 B2 minus A2 B1 equaled 0, then essentially these two equations would be the same equation, so they'd be the equation of the same line, so that would have infinite solutions, as every point on that line would correspond in both lines, plotted lines, the equation, the line that these equations represent. But where the denominator, where these are two different lines, this is a non-zero solution. A1 B2 minus A2 B1 is non-zero, and therefore we have a unique finite solution, a finite value for x. Okay, so we need, or it is useful to have a shorthand way of representing this term. That's quite an important thing in solving simultaneous equations, or when we come on to apply these to matrices for solving systems of simultaneous equations, or looking at stiffness matrices in our structures. Okay, so we have a way of representing that, and the way that the notation that we use to represent that, A1 B2 minus A2 B1, we say is represented in this format: A1 B1 A2 B2, by these, bounded by these two lines. And we, in order to get to that, we must multiply the terms diagonally to form the product in the expansion that we want. So we multiply A1 times B2, and then we subtract the product of A2 B1. Okay, so we have the positive of that diagonal's product, and then we subtract the product of this diagonal. Okay, so in our particular case, A1 B1 is 2 3, and A2 B2 is 3 4. If we take this thing that we are going to call the determinant, so it's a determinant of the second order, and we calculate its value by 2 times 4, so this diagonal times this diagonal, which is 8, and then we subtract this diagonal times this diagonal. 3 3s are 9, so we get -1, which is what we got down here. Came to -1 in our specific case, and that so the determinant of this, or this is the determinant of those, which gives us this term here, which is this diagonal multiplied together, take away this diagonal multiplied together. Okay, and that is the concept of a determinant, a second order determinant. So there are two rows and 2 columns.